C++ classes can have static variables just like any other language. However, since C++ is a little bit of a dinosaur language, forgive me for those who are very passionate about the language, basically the idea with C++ is it takes us a little higher than assembly language or processor. It's ancient, it's old. There's a lot of things that have some artifacts that have come with the language. And anyway, static variables, the reason we have to do static variables a little differently in C++ than we would in Java and C# is simply because of how the compilation units are made and then they're linked together and that kind of thing. Anyway, let me just show you here. Let's make a class, my class, and I'm going to make a static variable, static int my int, let's say static int, and gets 5. Well, this is how you would do it in Java or C#, is you just assign it. But notice here we're getting a complaint. Error, remember with an in-class initializer must be const. Alright, well, const is another issue, but all we're trying to do is define some memory, some RAM, for a static integer, and that is shared amongst all instances of my class. Well, remember that when you say class my class, this is actually a declaration, and hopefully you paid attention to that in the earlier assignments, that a declaration says kind of what, and the definition is this is it, meaning give me RAM. Alright, so when we declare this class, this is a blueprint for a class. We said there's an int, it's called my static int, but we haven't defined any memory for it in the static space. So the way we actually define RAM, take up RAM in the program image, is we have to come out here into the compilation unit and it looks a lot like we're redeclaring it, but what we're actually doing is defining it. So this is the declaration. Let's actually define it. Int my class, colon, my static int. And now I can initialize it out here. If you think about it, static, I can declare int another int. Gets 5, and well, let's do 50, a different number. But another int here, it's also static. It doesn't belong to any particular class. It's just out there in static memory, and anybody who references another int will read and write that int. So I could make a foo function here, and it could print another int, something or other, and then I could make a goo function, and they're both sharing this another int because another int is defined in the static space, and that's all we're doing here is we're defining another int that's static called my static int. It just so happens though it has some scoping, and that scoping is in the scope of my class. And my class really only exists to C++. It doesn't exist to the actual native code that's generated by C++. This is simply a conceptual thing that the C++ compiler enforces for us, is scope. Now, it also may seem a little weird to you that, remember, the default visibility for a class is private. In fact, if it makes you feel more comfortable, I can put private here. And this might feel a little weird that you're kind of accessing, in a way, this private int of a class, but that's how you do it. We're defining it. Now if I want to access, let me put public here, and void some function, and maybe some function. All it's going to do is increment my static int. Okay. Now, since this function is in the scope of my class, sure, it can see the private static. That's no problem. But if I come out here and I want to say my class and I want to access this private data member, I have to use the scope resolution, my static int, and that's kind of funny that IntelliSense brings that up and does auto completion, because really the my static int, it's private. In fact, well, you see the red squiggly, but let's build this and you get the error. Hey, it's you can't access private. So anyway, that's static in a nutshell. If it's public, that would take care of this down here. But static class members, declaration, definition. Now remember, usually these, in fact almost always, these class declarations should be in a separate header file. So if I did put this in a separate header file, in fact let me do that real quick. So here I've made a header file and I moved my class to it, and I put inline here on some function just so I didn't have to put in a CPP file. But now think of this, header files really don't mean anything. They're just declarations. The actual meat of your code are those compilation units, the things we create from the CPP files. And so And in fact, the .h files don't create any memory at all. They're just copy and paste jobs into the .cpp files. So in order to actually have some RAM for my static int, well, here let's include, I think I called it my class.h. To actually have some RAM for my static int, I have to define it in the compilation unit. All right. So think about this. If I move this definition of this int, I put it in the .h file right here, and then I include this .h file in 2 or more compilation units, meaning CPP files. That means this definition would be copy and pasted into all those CPP files. So then the compiler would be happy. It would compile each one of those CPP files fine. But then you have the OBJ files. And the OBJ files, each one of those OBJ files would have RAM defined in the program image for my static int. So then the linker would come along after trying to link it and say, hey, there's a lot of my static ints here. There's too many. There's only supposed to be one. And they're all over the place. They're multiplying like rabbits. So then we get a linker error. Here, I'll just show you. So here in my Solution Explorer, I have 2 CPP files or compilation units, and I included my class H here and my class H here. And if you remember from the preprocessor videos I showed you, it's basically the preprocessor opens my class H in both cases and pastes them directly in. And then these CPP files are compiled separately. Anyway, so you can, if you look at my class H again, it has this definition here for this static variable, which we have happened to paste in this file and paste in this file. So I build it, and the compiler is fine, but the linker comes back and says, hey, my static int already defined in another OBJ file. So what do you want me to do? There's 2 and there really should be 1. Anyway, I think the main thing to drive home from this is whether we declare int my static int gets 5 or int another static int gets 10. If another static int is in some other class, this part right here is simply just scoping. That's it. It restricts visibility. That is it. Other than that, the 2 variables are the same. They're stored the same in the program image, depending on whether they're initialized or not, and so on and so forth. So there you go. Statics, class statics.